right, we're going to go ahead and start second part of our lesson 1.2. Yesterday we were talking about the vertex form of the quadratic function, and today we're going to be talking about a different form even yet, which is the intercept form. So I hope you're ready. This should be a pretty short video as well. You're going to be able to graph quadratic functions in intercept form, and you're going to also be able to convert quadratic equation in intercept form or vertex form into standard form. So now we have three. After today's notes, you'll have three different forms of the quadratic. So let's recall the first two that we know. Y equals ax squared plus bx plus c, and to find the vertex we had to use this little formula here to find x, and then we plugged it in to find y for the vertex. And then yesterday we talked about the vertex form, which was even more simple than that because we saw the vertex in our h and k values. And then today we are going to be taking a look at the factored form. It's also called the intercept form. So that's going to be a times x minus p times the quantity x minus q. And we have a couple of definitions that we want to take a look at. The x-intercepts are going to be the 2 points that intersect the x-axis. Remember, the parabola that we have is always going to be symmetrical. So if it hits the x-axis, let's suppose this is the x-axis here, and if we have one x-intercept, then we always have another because, as we know, our parabolas are symmetrical. So let's define this as a point on the graph that intersects the x-axis. And of course, we know that there are two because the quadratic graph is symmetrical. So we know that there will be two. And this is because the quadratic, we'll say since parabolas are symmetrical. And the zero product property, if two numbers multiply to 0, then that means one of the two numbers that was multiplied has to be 0. So we'll write this out. When the product of a number is 0, so suppose we have some number a multiplied by 0, then of course that is going to be 0. So all of this product property is saying is that if the answer is 0, then one of those two numbers that we multiplied together has to be 0 also. 0 times any number is 0. All right, let's take a look at our first example. You'll notice here that there's a new form here for our function. It's still a quadratic equation, but first of all, we're just going to take the information that we have and find the x-intercepts. That's going to get us 2 points on our curve. And so what we're going to do is we're going to make y 0. So we're going to plug 0 into our factored form of the quadratic. So we're going to say 0 equals x plus 3 and then times x minus 1. So basically we're just going to set both of these things. Sorry, I forgot the a value, which is 2. We're going to set both of these binomials equal to 0. So 0 equals x plus 3 and 0 equals x minus 1. We already know that if one of these binomials is 0, if this one is 0, then this entire side of the equation is going to be 0 because whatever we multiply 0 by becomes 0. Okay, so we're just going to see, well, if we want to find out when y is 0 what x is, we can just set one of those binomials equal to 0. And if I subtract 3 from this side and subtract 3 from this side, then x is negative 3. And if I add 1 to this side and add 1 to this side, then x is equal to 1. So I found two places that when y is 0, x has a value. X has a value at negative 3 on the x-axis, and also it's going to hit the graph here at 1. So when y is 0, then those are our values for x. Remember that y is 0 all along the x-axis. All right, the second step, find the axis of symmetry of the equation by averaging the x-intercepts. The word average just means to add them together, so we're going to add together negative 3 and 1 and take its average. So negative 3 plus 1 equals negative 2, and if we take the absolute value of that, okay, that's just going to be 2. So we're going to go 2 units from negative 3, and that is going to be negative 1. I'm putting my axis of symmetry because that's halfway between the 2 points where the graph hits the x-axis. So halfway between negative 3 and 1 is negative 2, negative 1, and that's because it's 2 units from each of those places. All right, now I have to find the vertex itself. So I'm going to use the axis of symmetry to find the coordinates of the vertex. I already know that negative 1 is the x value because that's where I have my axis of symmetry. So I'm going to plug negative 1 back into my function. So I'm going to say y equals 2 times negative 1 plus 3, and then negative 1 minus 1 is in the other binomial. So when I work that all out, and I'll do that here, 2 times 2 times negative 2. So I'm going to end up with negative 8 here. And so therefore my vertex is negative 1, negative 8. So I can just plot that right here. And I could add a couple of other points. I could find out what the value is when y is 0. But I'm just going to go ahead and plot these 2 points. So we really only need 3 points to graph a quadratic, correct? All right, let's go to the back side of our paper. One of our objectives in this set of notes is converting quadratic equations in intercept form back into standard form. So we want to get our function, and we're talking about this function right here, back into this form, which is the standard form. And to do that, we're going to use the FOIL method. Maybe you've done this before when we have the first numbers multiplied together and then the outside numbers multiplied together and then the inside, and they may not be numbers, sometimes they're variables, and then the last 2 are going to be multiplied together as well. So looking at this one, and really it should say y equals x plus 6 and x minus 2 here. So I'm going to take my first values, multiply them together. X times x is x squared. And then I'm going to do the outside. The outside would be the x and the negative 2. And that would just be negative 2x. And then I'm going to do my inside. 6 times x is positive 6 times x is 6x there. And then my last 2 have to be multiplied together. Positive 6 and negative 2 is negative 12. And now I'm going to combine the things that are alike to try to simplify this statement. So my final new form, or my standard form, when I put it back into standard form, is going to be x squared plus 4x minus 12. And for problem A here, it looks like we have an A value of negative 2. I'm going to ignore that for just a second. And then at the end, I'm going to multiply everything by negative 2, sort of like what I did here, except everything would be multiplied by negative 2. So let's get started. We have x plus 5 and x minus 8. All right, so we just can't forget to go back and multiply everything by negative 2. So my first things are going to be x squared. My last things are going to end up being negative 8x. My inside things, actually those weren't last, where they x times negative 8 was outside, now the inside, so that's 5 times x. And then the last things is negative 40, negative 8 times 5. So if I'm going to combine the things that are alike, these things can be combined, x squared minus 3x minus 40, and now I'm going to bring my negative 2 and I'm going to multiply everything by negative 2. So my final answer for this one is going to be negative 2x squared plus 6x, because remember, negative 3 times negative 2 ends up being positive 6, and this ends up being positive 80 as well, because negative 2 times negative 40 ends up being positive 80. And I really should write y equals, because the standard form begins with y equals, and here's my final answer. Okay, a little bit more work when the function starts off in vertex form. This is our vertex form. Remember, h and k are pretty obvious here. And now we need to ignore, we're going to ignore this for just a moment, and we're going to ignore this for just a moment, and we're just going to deal with our binomial. Remember, this little symbol right here, squared, means that we're taking x minus 1 and multiplying it by itself. And so when I do that, I'm going to do the FOIL method here. X squared minus x, because negative x times x is negative x, another negative x, and a positive 1. Okay, to combine what I have that is alike, I'm going to end up with x squared minus 2x plus 1. Now I have to remember to bring this 4 right here, multiply that by everything. And some of you might be wondering, why am I not adding the 2 right now? Well, I can't do that until the very end. I'll have to do that after I multiply the 4. Remember, the order of operations says that we need to make sure we do things multiplying first. Okay, so right down here, I know I'm getting into the next set here, but hopefully you're writing a little bit smaller than I am. And I'm multiplying everything by 4, just distributing that out. Okay, now I can remember to bring down this, add a 2 to that. And so my final answer, I'm running out of space here, is going to be y equals 4x squared minus 8x plus 6. Okay, I guess I should have warned you ahead of time. I didn't realize that I would end up kind of writing all over the place. I hope you wrote a little bit smaller, more neatly than I did on my iPad here. All right, well, you have a couple of practice problems to do down here at the bottom. Okay, so first of all, you're going to take the new form, which is called intercept form, find the 2 places that the graph is going to touch the x-axis, and then plot your line of symmetry or axis of symmetry, and then you're going to find the vertex by knowing what that x value is for the axis of symmetry. And then at the bottom here, I would like you to try converting each of these back to the standard form of the equation, and that's just going to be the FOIL method. Okay, so just like I did. Now, if you have questions, you can make sure that you write them down on here. I'll definitely answer any questions that you have in class. Good luck.